Lesson 10 Trigonometric Functions and Equations. Hello everyone, my name is Dennis. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out important updates from me. Basic Trigonometric Ratios. You may be wondering, what is trigonometry? Trigonometry is a study of a right angle triangle. It involves angles and the sides of the triangle. Now, look at this diagram. Let's say, from the x-axis, we make a certain angle theta, and from here, we can form a right angle triangle. Now, from this right angle triangle, we can label the sides. Let's say this side, it is the opposite sides of the angle theta, and we label it as A. This side is the adjacent side because it is near to the angle theta, and we label it as B. This side is the longer side, and it is called hypotenuse. We can label it as C. Now, let's discuss about the trigonometric ratios. You can remember the trigonometric ratios with trois, quart, so, which means trois for tangent theta, it is equals opposite over adjacent. And based on this diagram, it is equals A over B. Quart means cosine theta, which equals adjacent over hypotenuse, and from this diagram, it is equal B over C. So, means sine theta equals opposite over hypotenuse, and it is equal A over C based on this diagram. So, you can remember this formula easily with the abbreviation of trois, quart, so. There are some certain names which is the reciprocal of this trigonometry. The first one, cotangent theta equals 1 over tangent theta, which is equal B over A. The second is secant theta equals 1 over cosine theta, which is equal C over B. Cosecant theta equals 1 over sine theta, which is equal C over A. You notice that I bold the third letter because the third letter tells us which reciprocal of the trigo it represents. For the first one, cotangent theta, the third letter is T, so it is 1 over tangent theta. For secant theta, the third letter is C, therefore it is the reciprocal of 1 over cosine theta. For cosecant theta, the third letter is S, therefore it is equal 1 over sine theta. So by looking for the third letter of this trigo, you know which reciprocal of the trigo it represents. Now, let's look at this ratio, sine theta to cosine theta. From the diagram, we know that the sine theta equals A over C and cosine theta equals B over C. So, we can rewrite it, which is A over C divided by B over C. The division sign we can change to the multiplication sign, and it will be A over C times C over B, which is A over B. From here, we can notice that A over B equals tangent theta. Hence, we can say that tangent theta equals sine theta over cosine theta. Therefore, cotangent theta equals cosine theta over sine theta. So please remember all the formulas boxed in red here. Complementary angles. In a previous slide, we have discussed the trigonometric ratios for this angle theta. Now, how about its complementary angle, which is this angle, and equals 90 degrees minus theta? So, if we are referring to this angle, 90 degrees minus theta, the B now is the opposite side, the A is the adjacent side, and C still remains the hypotenuse. By applying the formula 3 so tangent 90 degrees minus theta will be equals opposite over adjacent, and it is equal B over A. Comparing this ratio to the trigonometric ratio for the theta, it is equal cotangent theta. For cosine 90 degrees minus theta, it is equal adjacent over hypotenuse, which is A over C, and it is equal sine theta. For sine 90 degrees minus theta, it is equal opposite over hypotenuse equals B over C. It is also equals cosine theta. Therefore, from here, we can see the relationship between the theta and its complementary angles 90 degrees minus theta. Tangent 90 degrees minus theta equals cotangent theta. Cosine 90 degrees minus theta equals sine theta. Sine 90 degrees minus theta equals cosine theta. How about its reciprocal? For cotangent 90 degrees minus theta, it is equal 1 over cotangent theta, which equals tangent theta. For secant 90 degrees minus theta, it is equal 1 over sine theta, which also equals cosecant theta. For cosecant 90 degrees minus theta, it equals 1 over cosine theta, which equals secant minus theta. Therefore, cotangent 90 degrees minus theta equals tangent theta. Secant 90 degrees minus theta equals cosecant theta. And cosecant 90 degrees minus theta equals secant theta. Again, please remember all the formula boxed in red here. Now, let's discuss supplementary angles. So, now we form an angle starting from the x-axis to an angle of theta, which is more than 90 degrees. We can get its supplementary angles, which is this one, and it equals 180 degrees minus theta. From here, we can form a right angle triangle with this length as A, this length as negative B, and this length as C. So if we refer the 180 degrees minus theta, A will be the opposite length, B will be the adjacent side, and C will be the hypotenuse. By applying Tuakaso, for tangent 180 degrees minus theta, it equals A over negative B, which is equal negative tangent theta. For cosine 180 degrees minus theta, it equals negative B over C, and it equals negative cosine theta. For sine 180 degrees minus theta, it equals A over C, which also equals sine theta. Therefore, we can make a conclusion that tangent 180 degrees minus theta equals negative tangent theta. Cosine 180 degrees minus theta equals negative cosine theta. Sine 180 degrees minus theta equals sine theta. How about its reciprocal? For cotangent 180 degrees minus theta, it equals 1 over negative tangent theta, which also equals negative cotangent theta. For secant 180 degrees minus theta, it equals 1 over negative cosine theta, which also equals negative secant theta. For cosecant 180 degrees minus theta, it equals 1 over sine theta, which also equals cosecant theta. Hence, cotangent 180 degrees minus theta equals negative cotangent theta. Secant 180 degrees theta, 180 degrees minus theta equals negative secant theta. Cosecant 180 degrees minus theta equals cosecant theta. Please remember the formula boxed in red here. In summary, here are a few formulas that you need to remember. Tuakaso, which means tangent theta equals opposite over adjacent. Cosine theta equals adjacent over hypotenuse. Sine theta equals opposite over hypotenuse. Its reciprocal, cotangent theta equals 1 over tangent theta, which equals adjacent over opposite. Secant theta equals 1 over cosine theta equals hypotenuse over adjacent. Cosecant theta equals 1 over sine theta equals hypotenuse over opposite. Tangent theta also equals sine theta over cosine theta. Therefore, cotangent theta equals cosine theta over sine theta. Complementary angles. Tangent 90 degrees minus theta equals cotangent theta. Cosine 90 degrees minus theta equals sine theta. Sine 90 degrees minus theta equals cosine theta. The reciprocal, cotangent 90 degrees minus theta equals tangent theta. Secant 90 degrees minus theta equals cosecant theta. Cosecant 90 degrees minus theta equals secant theta. Supplementary angles. Tangent 180 degrees minus theta equals negative tangent theta. Cosine 180 degrees minus theta equals negative cosine theta. Sine 180 degrees minus theta equals sine theta. The reciprocal, cotangent 180 degrees minus theta equals negative cotangent theta. Secant 180 degrees minus theta equals negative secant theta. Cosecant 180 degrees minus theta equals negative cosecant theta. Also, if theta is between 0 to 90 degrees, it is acute angle. If theta is between 90 degrees to 180 degrees, theta is obtuse angle. If theta is between 180 degrees to 360 degrees, theta is a reflex angle. Please remember all the formula here. Now, let's look at this example. Given that secant theta equals 17 over 15 and theta is an acute angle, find the value of each of the following without using a calculator. 1. Sine theta. 2. Tangent 90 degrees minus theta. 3. Cosine 180 degrees minus theta. Here is the solution. Given secant theta equals 17 over 15, which means cosine theta is equal 15 over 17 because they are reciprocal to each other. So from this information, we can sketch the right angle triangle where this is the angle theta. So the side here, adjacent side is 15, the hypotenuse is 17. Then by using Pythagoras theorem, we can find the opposite side A. So A equals 17 square minus 15 square, then we square root the whole thing. So the answer is 8. Now we can find sine theta. So we know sine theta is SOH, opposite over hypotenuse. So for this case, will be 18 over 17. Next, tangent 90 degrees minus theta. So which is 1 over tangent theta. And if is equal, adjacent over hypotenuse, the value will be 15 over 8. 3. Cosine 180 degrees minus theta, which equals negative cosine theta. And cosine theta is adjacent over hypotenuse, then negative cosine theta will be negative 15 over 17. Now, you can try this example yourself. Given that cosine A equals 12 over 13 and A is an acute angle, find the value of each of the following without using a calculator. 1. Secant A. 2. Tangent 90 degrees minus A. 3. Sine 180 degrees minus A. You can pause the video and try to do it yourself. Here is the solution. From the information given, cosine A equals 12 over 13. We can sketch the triangle. This is the angle A. So cosine A is CAH, right? Adjacent side 12, hypotenuse is 13. So the opposite side will be A. Using Pythagoras theorem, A equals square root of 13 square minus 12 square, then which is 5. So we can get the value for secant A is 1 over cosine A, which is hypotenuse over adjacent. So the answer will be 13 over 12. 2. Tangent 90 degrees minus A, which equals 1 over tangent A. So the ratio is adjacent over opposite, and the value is 12 over 13. 3. Sine 180 degrees minus A, which equals sine A. So SOH, opposite over hypotenuse, it will be 5 over 13. So do you get all the answer correctly? Alright, now we come to one very, very important part of trigonometry. So you need to understand this concept very well before you want to learn further in trigonometry. So the concept is the concept of four quadrants. So this is the x and the y axis. So we can actually label this diagram into 4 parts. So this part, or this region is named as the first quadrant. Okay, so this quadrant, the value of x and the value of y are positive. Then this region is the second quadrant, where you can see that the x values, all the x values are negative and all the y values are positive. So this is the third quadrant. So for this region, both the x and the y axis, or both the x and y values, they are negative. And lastly, this is called the fourth quadrant. Okay, so the fourth quadrant, all the x values are positive and the y values are negative. Okay, now let's move on, So we take the x-axis as our reference, and we start to rotate with a certain angle, theta. Okay, and we can draw a straight line here, right? And after that, we can, for the first quadrant, it is, the angle is 0 to 90 degrees. Okay, and then let's say this is A, and this is B. Right, we actually can get a right angle triangle here. Okay, so this is A, right? This side is A, this side is B, the length. Okay, this is the hypotenuse, right, is C. Okay, now we can apply Tokaso, right? We start with the sine theta, which is SOH opposite over adjacent. So will be A over C. Cosine theta, K adjacent over hypotenuse. So it will be B over C. And tangent theta equals, so TOA, right, opposite over adjacent, A over B. Okay, from here, you can notice that all the trigonometry, sine, cosine, and tangent, all are positive. Now, let's move on to the second quadrant. So imagine we have rotated the angle is between 90 degrees to 180 degrees. Okay, so this is the line, right? And this is called the basic angle alpha. Okay, then from here, let's say the coordinates here is A, the y coordinate is A, the x coordinate is negative B. So this length will be A, this length will be negative B. And this is the hypotenuse C. So now again, we apply Tokaso, right? For sine theta, SOH will be opposite over adjacent, opposite over hypotenuse, which is A over C. Cosine theta is K adjacent over hypotenuse, negative B over A over C. Tangent theta is equal A over negative B. So twa, right, opposite over adjacent. So A over negative B. So from here, we can make a conclusion that in second quadrant, only sine is positive. Okay. Now let's move on, right? We rotate into the third quadrant, okay, where the theta is between 180 degrees to 270 degrees. So this is the line, right? So we have, this is the basic angle. So basic angle alpha always measure from the x-axis to the line. Okay, so we can take this is a negative A. So as I said just now, third quadrant, right? All the y values and the x values are negative. So this is the negative B, right? So, and this side will be negative A, and the length, this side, the length will be negative B. And the hypotenuse is always positive, so this is C. So again, we apply Tokaso, sine theta. So opposite over hypotenuse will be negative A over C. Cosine theta, adjacent over hypotenuse. So for this case, will be negative B over C. Tangent theta will be opposite over adjacent. So negative A over negative B, which is A over B. So from here, again, we can make a conclusion. In third quadrant, we notice that only tangent is positive. Sine and cosine are negative. Okay, now we rotate to the fourth quadrant, okay, where the theta is between 270 degrees to 360 degrees. So this is the line, and this is the basic angle alpha, again measured from the x-axis to the line, to the red line here. Okay, so we take the coordinates here. The y coordinate is negative A, the x coordinate is negative B. So this length will be negative A, this length will be negative B, positive B. Alright, so this length will be C. Okay, so then Tokaso again, sine theta, opposite over hypotenuse will be negative A over C. Cosine theta, adjacent over hypotenuse will be B over C. And tangent theta will be negative A over B. Alright, again, from here we can make a conclusion to say that in fourth quadrant, only cosine is positive, sine and tangents are negative. Okay, so now here we have special case where when the red line is on the positive side of the x-axis, right? Then that means that the angle theta will be 0 or 360 degrees. Okay, so you can notice that this is B, the length is B, it is also C, so C equals to B. While for A, right, it is 0. Okay, so that means sine 0 will be equals A over C, which is 0 over C, and sine 0 is 0. For cosine 0 degrees, it is B over C. Okay, since B and C are equal, so it will be B over B, which is 1. For tangent 0 degrees, it is A over B. So A is 0, so it will be 0 over B, and tangent 0 is 0. So the second special case is when the red line, right, it is at the y positive side of y-axis. So this is the angle, and the angle is 90 degrees. Okay, again we can notice that this is length A, this is length C. So length A or length C equals to length A, while B is 0. Therefore, for sine 90 degrees, it is A over C, and since both are the same value, A over A, so sine 90 degrees will be equals 1. For cosine 90 degrees, it is B over C, and we know that B is 0, so it's 0 over C. The answer is 0. For tangent 90 degrees, it is equal A over B, and since B is 0, then it will be A over 0, which is infinity. So to remember these special angles. Now the third special case will be when the line is on the negative x-axis. So from here, the angle theta is 180 degrees. So this is negative B. That means that the length here is negative B, same as C, right? So this length also C. It means that C equals to B, while A equals to 0. Therefore, for sine 180 degrees, it is A over C. A is 0, so it will be 0 over C. So sine 180 degrees will be 0. For cosine 180 degrees, it is negative B over C. Since both are the same value, then it will be negative B over B. So cosine 180 degrees will be negative 1. Do take note that C is always positive. Next, tangent 180 degrees. So it will be A over negative B. Since A is 0, it will be 0 over negative B. And tangent 180 degrees will be 0. Next, the fourth special case will be when the line is on the negative y-axis. So which means theta is 270 degrees. So from here we can see that this is negative A. That means this length will be negative A. The C is A. B is 0. So for sine 270 degrees, it is negative A over C, which means it is equals negative A over A. Since C equals A, so sine 270 degrees will be negative 1. For cosine 270 degrees, it is equal B over C. And since b is 0, it will be 0 over c, and cosine 270 degrees will be equals 0. So for tangent 270 degrees, it is equal a over b. So since b is 0, it will be a over 0, and again it will be infinity. Okay, now let's discuss about negative angles. So what does negative angles mean? When the bar turns in opposite direction or it is in the clockwise direction, angle is measured in negative value. So let's look at this diagram. This is the x and the y axis. So if the angle is turned in this direction, right, or the bar is turned in this direction, right, it will be negative theta. Okay, turn in the clockwise direction, right? So now we see that it is in a fourth quadrant, right? That means that sine negative theta will be equals negative sine theta. Cosine negative theta will be equals cosine theta, and tangent negative theta will be equals negative tangent theta. Okay, please remember this. Okay, let's look at some examples. If theta equals negative 30 degrees, okay, we update the diagram. This is 30 degrees. In the fourth quadrant, the alpha or the basic angle alpha equals modulus theta, which means sine negative theta, sine negative 30 degrees equals negative sine 30 degrees. Cosine negative 30 degrees equals cosine 30 degrees. Tangent negative 30 degrees equals negative tangent 30 degrees because they are in the fourth quadrant. Okay, let's look at another angle. Theta equals negative 120 degrees. So we can draw the diagram, which will look something like this, right? So this is the negative 120 degrees, and we can see that this is in the third quadrant. Okay, if we turn in the anti-clockwise direction, right, it means that negative 120 degrees will equals to 360 degrees minus 120 degrees, and it is 240 degrees. Okay, it is in the third quadrant. Therefore, sine negative 120 degrees equals negative sine 60 degrees. Okay, which is the basic angle alpha equals 60 degrees, which means it is equal negative sine 120 degrees. For cosine negative 120 degrees, it is equal negative cosine 60 degrees. Okay, then it is equals cosine 120 degrees. Tangent negative 120 degrees equals tangent 60 degrees. Okay, or equals negative bracket negative tangent 60 degrees. Or it is equal negative tangent 120 degrees. Okay, if we move on, right, the theta equals negative 240 degrees, which means now it is in the second quadrant. This is negative 240 degrees, and if we turn in the anti-clockwise direction, it will be 120 degrees. And the base angle alpha is equal 60 degrees. Okay, it is in the second quadrant. Therefore, sine negative 240 degrees equals sine 120 degrees. Or it is equal negative bracket negative 60 degrees. Okay, and it is equal negative sine 240 degrees. For cosine negative 240 degrees, it is equal cosine 120 degrees, or it is equal negative cosine 60 degrees. Okay, because the alpha or the base angle is 60 degrees, right, in the second quadrant. Therefore, cosine 120 degrees is negative cosine 60 degrees, which means it is equal to cosine 240 degrees. For tangent negative 240 degrees, it is equal tangent 120 degrees. Okay, or it is equal negative tangent 60 degrees. Okay, this is referring to the base angle 60 degrees. And it will equals negative tangent 240 degrees. Okay, now let's move on to theta equals negative 300 degrees, which means referring to this diagram. So we rotate into this direction and the angle is negative 300 degrees. Okay, the basic angle alpha is 60 degrees. Alright, so that means negative 300 degrees equals 60 degrees. It is in the first quadrant. Therefore, sine negative 300 degrees equals sine 60 degrees. Or it is equal negative sine 300 degrees. For cosine negative 300 degrees, it equals cosine 60 degrees, which also equals cosine 300 degrees. For tangent negative 300 degrees, it is equal tangent 60 degrees, or it is equal negative tangent 300 degrees. Okay, so from here we can make a conclusion, right? For the negative angles, so it obeys the formula sine negative theta equals negative sine theta, cosine negative theta equals cosine theta, and tangent negative theta equals to negative tangent theta, regardless where the angle is, whether it is in the first quadrant, second quadrant, third quadrant, or the fourth quadrant. In this section, I want to discuss about how sine, cosine, and tangent graphs looks like, how we get these graphs. Okay, so we start with the sine graph. Okay, we have a table here, and this is the x and the y-axis. For the x-axis, we label it as theta. Okay, the y-axis is y. Okay, the equation is y equals to sine theta. Okay, so firstly, we start with the theta angle as 0, right? Okay, then move on 90 degrees, which is pi over 2. Okay, so let's say this is 90 degrees. Then the next one will be 180 degrees, which is equal pi as well. So this is 180 degrees. Then 270 degrees, or 3 pi over 2. So this is 270 degrees. Then 360 degrees, or equals 2 pi. So this is 360 degrees. Okay, so sine theta, as we have learned just now, right? For sine theta, it is 0. Okay, so we plot on the graph, right? This part will be 0. When the angle theta is 0, sine theta will be 0. Okay, and we know that sine 90 degrees, it is equals to 1. Okay, right? So let's label here is 1. Okay, the 90 degrees here, we plot the point here. Next, we move on to 180 degrees. We know that sine 180 degrees equals 0. Then we plot on a graph. So when theta is 180 degrees, right, y is 0. Now we move on to 270 degrees, right? We know that it is negative 1. Okay, so let's say this is negative 1. Okay, 270 degrees, we plot here, y is negative 1. Alright, now the last one, 360 degrees. Okay, we know that it is 0. So plot on the graph, this is 0. Okay, now we can go to the special angles, right? When theta is 30 degrees or pi over 6, sine theta will be, okay, we label on the graph first, right? 30 degrees, 45 degrees, or pi over 4. So 45 degrees, 60 degrees, pi over 3. So on the graph, this is 60 degrees. Okay, and we can update the value here. Sine 30 degrees is 1 over 2, which is half here, or 0.5. Okay, 45 degrees is 2 over 2. Okay, so this is the point here. So sine 60 degrees is 3 over 2. So this is the point here. Alright, and we can join these points to form this curve. Okay, now move on to 120 degrees, which is also equal to 2 pi over 3. So on the graph, this is 120 degrees, 135 degrees, which equal 3 pi over 4. So this is 135 degrees, 150 degrees, which is 5 pi over 6. So this is 150 degrees. Okay, and then this value, right, or the graph are symmetry. So that's why sine 120 degrees is 3 over 2, which is at this point. Sine 135 degrees, which is 2 over 2, it will be at this point. Sine 150 degrees is 1 over 2 or half, which is at this point. Okay, again we join the points. Okay, we get this curve. Okay, now let's move on to the next angle, 210, which equals 7 pi over 6. So it will be at this, the value is negative 1 over 2. Okay, so which is negative 0.5. And the point is here. Okay, move on 225 degrees, which equals 5 pi over 4. So this is 225 degrees, and it is negative 2 over 2. Okay, which should be on this point. 240 degrees, it is equal 4 pi over 3. So this is 240 degrees, and sine 240 degrees equals negative 3 over 2. So plot on the graph, this is negative 3 over 2. And now we can join these points together, we get this curve. Okay, now move on to the fourth quadrant, right, which is 300 degrees equals 5 pi over 3. So this is 300 degrees, sine 300 degrees is negative 3 over 2. So this will be the point. Then 315, which equals 7 pi over 4. Okay, so 315 degrees, sine 315 degrees is negative 2 over 2. So this will be the point. And then 330 degrees equals 11 pi over 6. Okay, so update here, 330 degrees, sine 330 degrees is negative 1 over 2 or negative half. So it will be at this point. And now we join these points together, we get this curve. Alright, so at the end, we get this sine graph. Okay, so sine graph will look like this. Now we move on to cosine graph. Okay, we do the same thing, right? With the sine graph, we start with the x and the y-axis. We label the x-axis as theta. Okay, now the equation is y equals to cosine theta. Okay, and we start with the angles 0, right? So this is a 0 when theta is 90 degrees, which is pi over 2. So this is 90 degrees, 180 degrees or pi. So this is 180 degrees, 270 degrees or 3 pi over 2. So this is 270 degrees. 360 degrees equals 2 pi. So this is 360 degrees. Okay, and we know cosine theta here, cosine 0 is 1. Okay, we label here as 1. So this is cosine theta or cosine 0 is 1. Next, cosine 90 degrees equals 0. So plot on the graph. So this is at 90 degrees, y is 0. Theta is 180 degrees. So cosine 180 degrees is negative 1. Okay, we label here is negative 1. So when the angle is 180 degrees, y is negative 1. Okay, 270 degrees or equals 3 pi over 2. So cosine 270 degrees is 0. On the graph, we plot at this point. When theta is 270 degrees, y is 0. And the last one, 360 degrees, right? Cosine 360 degrees is 1. Okay, update on the graph. Here, this is when theta is 360 degrees, the y is equals to 1. Okay, then we can find the angles in between, right? For the first quadrant, theta is 30 degrees. So cosine 30 degrees is here, right? 45 degrees is equal to pi over 4. So on the graph, 45 degrees, 60 degrees equals pi over 3. So this is 60 degrees. Okay, cosine 30 degrees is 3 over 2. So plot on the graph. So it will be this point. Cosine 45 degrees is 2 over 2. On the graph, it will be at this point. Cosine 60 degrees is 1 over 2, which is half, right? So it's 0.5, which this is the point. And now we can join, these points together, we get this curve. Okay, move on to the second quadrant. So theta is 120 degrees, which also equals 2 pi over 3. So this is 120 degrees, 135 degrees, or 3 pi over 4. So this is 135 degrees, 150 degrees equals 5 pi over 6. So this is 150 degrees. Okay, so cosine 120 degrees is negative, so 1 over 2, or half, right? Negative half, so negative 0.5. 120 degrees, y is negative 0.5. Cosine 135 degrees, it is negative 2 over 2. So on the graph, this is the point. Okay. And cosine 150 degrees, right? It is equals negative 3 over 2. So this is the point. And now we join these points together. Okay, we get this curve. Right, now move on to the third quadrant. Right, theta is 210 degrees, which equals 7 pi over 6. So this is 210 degrees. And cosine 210 degrees is negative 3 over 2. So we plot on the graph, this is the point. Cosine 225 degrees, or 5 pi over 4. So this is the angle 225 degrees. So cosine 225 degrees is negative 2 over 2, which is this point. Now theta is 240 degrees, or 4 pi over 3. So this is the part, the angle 240 degrees. So cosine 240 degrees equals negative 1 over 2, or half, right? So this is the point. And now we join these points together to form this curve. Alright, now move on to the fourth quadrant. So when theta is 300 degrees, or 5 pi over 3. So this is the angle. Cosine 300 degrees is half. Okay, and plot the point, which is here. Now 315 degrees is equal to 77 pi over 4. So cosine 315 equals 2 over 2. So this is the point. Okay, and then angle 330 degrees is 11 pi over 6. So cosine 330 degrees equals negative 3 over 2. So plot on the graph, this is the point. And now we join all the points together, we form this curve. Alright, then we look at the overall picture. Right, so this is how cosine theta graph looks like. Okay, now we move on to tangent graph. Okay, so again we repeat the same process, right? This is the x and y axis. X axis is theta, y axis is y. So the equation is y equals tangent theta. We start with 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Okay, tangent 0 is 0. Tangent 90 degrees is infinity. So what we can do on the graph is we can draw a vertical dotted line at 90 degrees like this. Okay, which means that this is the asymptote. The curve will not touch this line. Okay, tangent 180 degrees is 0. Okay, which is this point. Tangent 270 degrees, it is infinity. Okay, so again we draw a dotted line, vertical dotted line at 270 degrees. So next, tangent 360 degrees is 0. On the graph, this is 0. Then after that, we can move on to the first quadrant. Tangent 30 degrees is at this point. Okay, 30 degrees, 45 degrees is at this point. 60 degrees is at this point. Okay, so tangent 30 is 1 over 3. Okay, which is somewhere here. Tangent 45 degrees is 1. Okay, so we draw this line as 1. But 45 degrees, the y is 1. Tangent 60 is 3. Okay, which is at this point. Right, and you notice that we can join the point here and it will bend up like this. Okay, now move on to the second quadrant. Theta is 120 degrees. So this is a region 130 degrees. Theta is 135 degrees, which is here. Theta is 150 degrees, which is here. Okay, now tangent 120 degrees is negative 3. Okay, plot on a graph. which is somewhere here. Tangent 135 degrees is -1, so this is -1. It is somewhere here at this point for tangent 135 degrees. And then tangent 150 degrees, it is here. The value is -1/3. Okay, plot on the graph, it will be at this point. Now we can join them together. Okay, we get this curve. Okay, and the curve will never touch the asymptote at 90 degrees. Okay, now we move on to the third quadrant. Theta is 210, which is here. So tangent 210 degrees is 1/3. Okay, we plot the graph, it is at this point. Tangent at 225 degrees. Okay, it is 1. On the graph, we plot it. Here is the point. Tangent 240 degrees, it is 3. Okay, on the graph, this is the point. And now we join this point together, we get this curve. Okay, move on to the fourth quadrant. Theta is 30 degrees, right? So, which is at this point, right? So tangent 300 degrees is -3. So this is the point. Tangent 315, okay, it is -1. Okay, it will be at this point. Then tangent 330 degrees, it is here, right? The value is -1/3, and this will be the point. And now again, we join this point together with and we'll form this curve. Alright, now we can look at the overall picture of tangent graph. It will look like this. Now, let's look at this example about solving simple trigonometric equations. Solve the following equations for the range of x from 0 to 360 degrees. A. Sine x equals 0.245. B. Sine 2x equals 0.245. C. Sine 2x plus 35 degrees equals -0.245. D. Sine 2x minus 35 degrees equals -0.245. You can notice that in this example, all the equation here, they have the same answer, which is equals to 0.245, but the range, the x is different. The A is for x, B is 2x, C is 2x plus 35, D is 2x minus 35. All these four questions, they involve the same trigo, which is sine. Alright, so when you see different angles, so when you want to find the answer, the approach will be slightly different. Let's see how we want to find the answer for these four questions. Here's the solution. For A, sine x equals 0.245. To get the answer, the steps are very easy. First step is you want to find the best angle, alpha. So for this case is equal inverse of sine 0.245, and if you press calculator, the answer is 14.2 degrees. And we know that sine is positive for this case, so it will be in the first and second quadrant. Now you can draw this diagram to see the whole picture. So the best angle is this angle 14.4 degrees, and also this angle 14.2 degrees. Okay, so it is from 0 to 180 degrees. Now we know that from this diagram, x equals 14.2 degrees or 180 degrees minus 14.2 degrees, which is x equals 14.2 degrees and 135 degrees, 135.8 degrees. Okay, so this is the answer for A. Now for B, sine 2x equals 0.245. The first step is the same as question A, which is the best angle alpha is inverse of sine 0.245, which is 14.2 degrees. Sine is positive, which is the first and the second quadrant. Now, we can draw this diagram out. This is the base angle 14.2 degrees. This is the base angle 40.2 degrees in second quadrant. Okay, it's 0.180 degrees here. Now we need to take one more step, is to check the range. Given the range of x is from 0 to 360 degrees, so 2x will be 0 to 720 degrees. Okay, so now the answer for this question is 2x equals 14.2 degrees, and 180 degrees minus 14.2 degrees, which will give us 14.2 degrees and 135.8 degrees. But our answer doesn't stop here. We can consider each of these angles plus with 360 degrees. Okay, so 14.2 degrees plus 360 degrees, or 135.8 degrees plus 360 degrees. So all the angles also need to divide by 2. Therefore, x equals 7.1 degrees, 67.9 degrees, 187.1 degrees, and 147.9 degrees. Okay, so to get the answer here, you need to double check as well that all the answers here, they must be within the range. So what do I mean? Let's say 2x. Okay, make sure these answers 14.2, 135.8 degrees, so plus 360 degrees for 14.2, 135.8 degrees plus 360 degrees. They must be between 0 to 720 degrees for the range of 2x. And when all the answers are divided by 2, for this case is 7.1 degrees, 67.9 degrees, 187.1 degrees, and 247.9 degrees. All this range, they must be between 0 to 360 degrees. Okay, if any of the answers are out of the range, then you can reject the answer. Okay, now we move on to solution for C. Okay, sine 2x plus 35 degrees equals negative 0.245. Okay, so I purposely put a negative answer here and see what will be the difference and what are the similarity of the steps. Okay, compare with A and B. Now, first step, still the same. You want to find the base angle alpha, which is equal inverse of sine 0.245. Okay, and the base angle is always positive, so it is 14.2 degrees. Next, now for C, right, the sign is negative. Therefore, it is in the third and the fourth quadrant. Okay, now we draw the diagram, fourth and third diagram. So base angle is here, 14.2, and this is 40.2 degrees in the third quadrant. So 0 to 180 degrees. Now the range for x is 0.360 degrees. So the range for 2x is from 0 to 720 degrees. Okay, and the range for 2x plus 35 degrees will be from 35 degrees to 755 degrees. Okay, so how we get this? What we need to do is from the range at the second row here, all of them, right, we plus with 35 degrees. So 0 plus 35 degrees, 2x plus 35 degrees, we get this. 720 plus 35 degrees, we get 755 degrees. Okay, so once we have identified the range, next step, okay, we can write out the answer. So 2x plus 35 degrees equals 180 degrees plus 14.2 degrees, or 360 degrees minus 14.2 degrees. So which will give us the answer, 194.2 degrees, 345.8 degrees. Okay, now look at the range, right? For 2x plus 35 degrees, it can go up to 755 degrees here. Okay, so what we can do is we can add another 360 degrees for each of the answers here. So which will be 194.2 degrees plus the 360 degrees, 345.5 degrees plus 360 degrees. Okay, now after that, right, we make x a subject for each of the answers here. So x will be equals 79.6 degrees, 155.4 degrees, 229.6 degrees, and 335.3 degrees. Okay, so again, when you want to write down the answers, right, always check whether the answers are within the range or not. Okay, we have to start from here. Okay, make sure all these answers 194.2, 345.8 degrees, and this plus 360 degrees, this angle plus 360 degrees, right? They are within the range from 35 degrees to 755 degrees. And when you get the answer for x, so make sure all this value, right, 79. So 79.6 degrees, 155.4 degrees, 229.6 degrees, and 335.3 degrees, they are within the x range, which is from 0 to 360 degrees. Okay, so these are the answers for C. Now we move on to D. So sine 2x minus 35 degrees equals negative equals to positive 0.245. So we find the base angle alpha equals inverse of sine 0.245. So which is 14.2 degrees. Okay, the same step. Now the next one, sine is negative. Alright, it is for the third and the fourth quadrant. So update again the diagram here, 14.2 degrees, 14.2 degrees here. So, and the range of x is from 0 to 360 degrees. So 2x will be from 0 to 720 degrees. Okay, and then we minus 35 degrees for all the sides here. So 0 minus 35 degrees, you get negative 35 degrees. 2x minus 35, 720 degrees minus 35 degrees, we get 685 degrees. Okay, so this is the range of the angle 2x minus 35 degrees. Now we can write down the answer. 2x minus 35 degrees equals, right, 180 degrees plus 14.2 degrees, 360 degrees minus 14.2 degrees. Okay, so 2x minus 35 degrees will be equals 194.2 degrees, 345.8 degrees. Okay, so we can still add another cycle, right? So 194.2 degrees plus 360 degrees, 345.5 degrees plus 360 degrees. Okay, so we have another angle which can be included here, which is the negative angle minus 14.2 degrees. Okay, so we can consider the negative angle because we'll check the range, right? The range is starting from negative 35 degrees. Okay, so for the angle of 2x minus 35 degrees, negative 14.2 degrees, right, it is still within the range, so we can consider this angle. Alright, so once we have all the answers, now we make x the subject. Okay, so the answer for D will be x equals 114.6 degrees, 190.4 degrees, 259.6 degrees, 335.3 degrees, and 10.4 degrees. Alright, so now it is your turn to try this similar example yourself. Okay, solve the following equation for the range of x from 0 to 360 degrees. A cosine x equals 0.245. B cosine 2x equals 0.245. C cosine 2x plus 35 degrees equals negative 0.245. D cosine 2x minus 35 degrees equals negative 0.245. You can pause the video and try to do it yourself. Okay, here is the solution. So for A, cosine x equals 0.245. So the first step, what we need to do is we need to find the base angle alpha, which is equals cosine inverse of cosine 0.245, and when you press calculator, the answer is 75.8 degrees. Okay, now for this case, the cosine is positive, therefore the angle is in the first and the fourth quadrant. So we can draw the diagram here, the quadrant diagram. Okay, this is the best angle, 75.8 degrees, 75.8 degrees in the first and the fourth quadrant. Okay, so the x will be 75.8 degrees in the first quadrant and 360 degrees minus 75.8 degrees for the fourth quadrant. Okay, the answer will be 75.8 degrees and 284.2 degrees. So this is the answer for A. Okay, now we move on to B. Cosine 2x equals 0.245. Alright, so the steps are very similar with part A. Okay, first step is to find the best angle. Alpha is inverse of cosine 0.245 and answer is 75.8 degrees. And cosine is positive, therefore it will be in the first and the fourth quadrant. We can draw this quadrant diagram. So in the first and the fourth quadrant here. Okay, now what's the next step? Can you still remember what we have seen in previous example? Okay, we want to check the range. Okay, so for this case, given the range of x is from 0 to 360 degrees and our angle is 2x, so the range for 2x, right, is from 0 to 720 degrees. Okay, so therefore we can get the answer for 2x equals 75.8 degrees, 360 degrees minus 75.8 degrees. So which will be the answer for 2x is 75.8 degrees and 284.2 degrees. But we can see the range, right? It can go up to 720 degrees. Okay, so this is the range for 2x. Therefore, the answers for these two, right, we can add another 360 degrees. So 75.8 degrees plus 360 degrees, 284 degrees, 284.2 degrees plus 360 degrees. So after that, we make x the subject. Okay, all angle divided by 2, right? X will be 37.9 degrees, 142.1 degrees, 217.9 degrees, and 322.1 degrees. Okay, so this is the answer for B. Okay, now we go to the answer for C. So cosine 2x plus 35 degrees equals negative 0.245. Alright, so the initial steps are very similar. Again, we want to find the best angle. Alpha equals inverse of cosine 0.245, which will give us 75.8 degrees. Okay, now cosine is negative, therefore it will be in the second and the third quadrant. So we can draw the quadrant diagram. So in the second and the third quadrant. So from here we know that okay, the next step, check the range. It is from for the range of x is from 0 to 360 degrees. So the range for 2x will be 0 to 720 degrees. After that, we add 35 degrees. Okay, 0 plus 35 get 35 degrees. 2x plus 35 degrees, and then right 720 plus 35 degrees, we get 755 degrees. Okay, then we can write out the answer. The second and the third quadrant, right? 2x plus 35 degrees equals 180 degrees minus 75.8 degrees. 180 degrees plus 75.8 degrees. Okay, then the answer is 104.2 degrees, 255.8 degrees. Okay, so we check the range, right? Always keep check the range, right? So it can go up to 755 degrees. So we can continue with another cycle for 104.2 degrees plus with another 360 degrees, 255.8 degrees plus another 360 degrees. Okay, then after that, always check the answer. Are all these within the range? Okay, I think yes, for all these cases, right, it is still less than 755 degrees. Then we make x a subject. Okay, so all the answers, right, just minus 35 degrees and then divide by 2. So therefore the x will be equals 34.6 degrees, 110.4 degrees, 214.6 degrees, and 290.4 degrees. Okay, so this is the answer for C. Okay, of course, one more thing you need to do, check the range. Okay, so for this case, it is this range. Okay, so all the answers are within 360 degrees. Okay, now move on to D. Okay, cosine 2x minus 35 degrees equals negative 0.245. So the basic angle alpha is the same step, right? So which is inverse of cosine 0.245, we get 75.8 degrees. And cosine is negative, therefore it is the second and the third quadrant. Update the quadrant diagram. Second and third quadrant, basic angle, okay, this line is 0 and 180 degrees. And now we check the range. Okay, x is from 0 to 360 degrees. 2x will be from 0 to 720 degrees. Okay, 2x minus 35 degrees, right? The range is from negative 35 degrees to 685 degrees. Okay, now we can write out the answer. Okay, 2x minus 35 degrees, right, will be equals 180 minus 75.8 degrees. 180 degrees plus 75.8 degrees. Okay, therefore 2x minus 35 degrees will be equals 104.2 degrees, 255.8 degrees. Okay, now check again the range, right? So the range for 2x minus 35 degrees, it is from negative 35 degrees to 685 degrees. So you can add another 360 degrees. Okay, so 104.2 degrees plus 360, 255 degrees plus 360. Okay, and then can we consider the negative angle? For this case, okay, it's not because it is not in the fourth quadrant. Okay, we can just ignore. Okay, so can you see that even if you include negative 75.8 degrees, right, it is outside the range. Okay, and negative angle is out of the range. Okay, actually we also don't have to we don't have to consider this because this is in the fourth quadrant, which is here. Okay, this is not our range, our quadrant as well. We want second and third quadrant. Okay, we ignore this angle. Okay, now we make x a subject. X equals 69.6 degrees, 145.4 degrees, 249.6 degrees, and 325.3 degrees. Alright, so do you get all the answers correctly? Okay, now we go to this example, which actually involve some certain special angles. Okay, so how special is it? Now let's look at the example here. Right, solve the following equation for the range of x from 0 to 360 degrees. Okay, sine x equal to 0, sine 2x equals to 0, sine 2x plus 35 degrees equals 1, sine 2x minus 35 degrees equals negative 1. Okay, so you can notice that, right, over here the sine, okay, of course firstly the trigger is the same, or the sine angles is different. The first is x, 2x, then 2x plus 35, 2x minus 35. Okay, and also, right, you notice that the trigo equals to either 0 or 1 or negative 1. So these are the few special values here. Okay, so how special is it? Now let's look at the solution first. For a, sine x equal to 0, okay, we know the range is from 0 to 360 degrees. Okay, now we want to draw the graph of sine x. Okay, so this is the graph of sine x. You notice that, right, sine equals to 0. So what are the points here? So these are the points. First is 0 degrees, or 180 degrees, or 360 degrees. Okay, so now the x will be 0, 180 degrees, and 360 degrees. Okay, you need to be careful here when you write out the answer. Okay, whether the range is inclusive of 0 or 360 degrees or not. Okay, so how you know, check the range here given, right? Okay, you can look at the answer, the question, right? the range given is included or not. Okay, or sometimes they don't just write directly the range, they will just tell in words. So they will say the range of x is from 0 to 360, whether they have the word inclusive or not. Okay, so you need to be careful, read it carefully. So this is the answer for A. Okay, now move on to B, right? Sine 2x is 0. Okay, range of x is 0 to 360 degrees. The range for 2x will be 0 to 720 degrees. Okay, now we can look at the graph now. So this is sine 2x, right? Okay, sine x, we have the range 0, 180, 360 degrees. We turn another cycle, right? For 550 to 720. Okay, so therefore 2x will be 0, 180 degrees, 360 degrees, 540 degrees, and 720 degrees. So again, be careful, right? Double check, always double check the range, right? All are within 0 to 720 degrees inclusive. So that's why you still can include 0, you still can include 720 degrees. Okay, then make x a subject. Every answer divide by 2, right? 0, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Right, so this is an answer for B. Okay, now we move on to look at solution for question C. Sine 2x plus 35 degrees equals to 1. Okay, now look at the range. X is from 0 to 360 degrees inclusive. Okay, the range for 2x is from 0 to 720 degrees inclusive, and then the range for 2x plus 35 degrees is 35 degrees to 755 degrees. Okay, so just take the 0 plus 35 degrees, you get 35 degrees, 720 degrees plus 35 degrees, you get 755 degrees. Okay, after that, we need to look at the graph here. Okay, so this is 0, 180, 160 degrees, but this is not the angles that we want, because we want the angle where the sine is 1. Okay, so we can turn another round because we have these 2x here. Okay, so the 1 will be this part, this point, which is at 90 degrees, and this point, which is at 450 degrees. Okay, so now the 2x plus 35 degrees will be equals to 90 degrees and 450 degrees. Then we make x a subject. It will be x equals 27.5 degrees or 207.5 degrees. Okay, so this is the answer for C. Now we move on to D. Sine 2x minus 35 degrees equals to -1, right? So the process is actually very similar, right? Given range is 0 to 360 degrees. Okay, the range for 2x with 0 to 720 degrees. The range for 2x minus 35 degrees will be -35 degrees to 685 degrees. Okay, the same thing, 0 minus 35, you get -35 degrees. 720 minus 35, you get 685 degrees. Okay, again, we look at the graph again, right? Okay, where is -1, which is this point at 270 degrees, and this point, which is 630 degrees. Okay, so from here, we can say that 2x minus 35 degrees equals 270 degrees and 630 degrees. So x will be 152 degrees and 332.5 degrees. Okay, so this is the answer for D. Do you get all the answers correctly? Okay, now it's your turn to try this similar example yourself. Solve the following equation for the x range of 0 to 360 degrees. A cosine x equals to 0, B cosine 2x equals to 0, C cosine 2x plus 35 degrees equals to 1, D cosine 2x minus 35 degrees equals to -1. You can pause the video and try to solve it yourself. Okay, now let's look at the solution here. A cosine x equals 0. So the range of x is from 0 to 360 degrees. Now we look at the graph here, we can't determine the quadrant. So where is the angle for cosine x equal to 0? So it is 90 degrees and 270 degrees. So therefore the answer for x is 90 degrees and 270 degrees. Okay, so this is the answer for A. Now for B, cosine 2x equal to 0. Okay, the range of x is from 0 to 360 degrees. And the range for 2x is from 0 to 720 degrees. Okay, now we look at the graph for cosine x. Okay, we need to have two cycles here because it is 2x. Okay, where is the angle when cosine 2x equal to 0? So this is the angle, 90 degrees, 270 degrees, also at 450 degrees and 630 degrees. Okay, so therefore 2x is 90 degrees, 270 degrees, 450 degrees, and 630 degrees. Now we make x a subject, divide everything by 2. So the x will be 45 degrees, 135 degrees, 225 degrees, and 315 degrees. So this is the answer for B. Okay, now we move on to solution for C. Cosine 2x plus 35 degrees equals to 1. Okay, the range of x is from 0 to 360 degrees. The range for 2x is 0 to 720 degrees. The range for 2x plus 35 degrees will be 35 degrees to 755 degrees. Okay, so again, to get the answer 35 here, right, is 0 plus 35. Okay, 720 plus 35, you get 755 degrees. All right, and then look at the cycle or the graph of cosine. Right, so two cycles here. Where is the one here, which will be this point at angle 0 degrees, this point at angle of 360 degrees, this point at the angle of 720 degrees. Okay, but take note, right, this point when x is 0, right, it is out of the range because it starts at 35 degrees. So we should not include this angle. Okay, now our answer will be 2x plus 35 degrees equals 360 degrees and 720 degrees. Okay, then we make x a subject. So x will be equals 162.5 degrees and then 342.5 degrees. So this is the answer for C. Okay, for D, cosine 2x minus 35 degrees equals -1. Okay, the angle of x is from, the range of x is from 0 to 360 degrees. 2x will be 0 to 720 degrees. Okay, the range for 2x minus 35 degrees will be -35 degrees to 685 degrees. Okay, again the same thing, 0 minus 35 degrees, -35 degrees, 720 degrees minus 35, we get 685 degrees. Okay, so look at the graph again. Where is the value for -1, right, which is this point at 180 degrees and this point at 540 degrees. Okay, so therefore 2x minus 35 degrees will equals 180 degrees and 540 degrees. Okay, we make x a subject, which will be x equals 107.5 degrees and 287.5 degrees. So do you get the answers correctly? So we have just finished discussing about solving simple trigonometric equation, and I hope that you can notice that when you want to solve the simple trigonometric equation, those steps are pretty similar. Okay, so actually we can further extend the steps, right, into slightly more longer equation, which means that it might involve longer steps. Okay, so for this section, right, we want to see one example, okay, to solve trigonometric equation in degree mode. Okay, now let's look at this example here. Find all the angles between 0 degrees and 360 degrees inclusive. Okay, so this is the word that I'm talking about, if it inclusive is inside the question or not. Okay, So if it is inside, that means we need to consider 0 and 360 degrees as well. Okay, now which satisfy the following equation. So 5 sine square x minus 6 sine x cosine x equal to 0. Okay, so slightly more longer equation here. So how we want to solve it? Okay, let's look at the solution here. So the given equation is 5 sine square x minus 6 sine x cosine x equal to 0. So we can factorize the sine x, which will become sine x, okay, bracket 5 sine x minus 6 cosine x equal to 0. So from here, we can start to solve it, right? We can say that sine x equal to 0 or 5 sine x minus 6 cosine x equal to 0. Okay, so you should be familiar with this equation, right? Sine x equal to 0. We can start to follow the steps here. So look at the sine graph. I want it to be 0. Then the angle will be 0 to 180 degrees and 360 degrees. So therefore, x will be 0, 180 degrees and 360 degrees. Okay, so inclusive 0 to and 360 degrees. So we can include these two angles. Now we move on to solve the second equation, right? So 5 sine x minus 6 cosine x equal to 0. So it will be 5 sine x equals 6 cosine x. Then we put the trigo at left hand side, the constant at right hand side. It becomes sine x over cosine x equals 6 over 5. Alright, so sine x over cosine x is tangent x equals 6 over 5. Now, we'll recall that tangent x is sine x over cosine x. Okay, so we can follow the steps, right? When we want to solve a simple trigonometry equation. Okay, then first step we want to find the best angle, which is inverse of tangent 6 over 5 for this case. Okay, and when you press calculator, the angle is 50.2 degrees. So from the ASTC, tangent is positive, right? Look at here, tangent is positive. So it is in the first and the third quadrants. Okay, now we can draw the quadrant diagram. The first and the third quadrant, right? Best angle is here, 50.2 degrees, and is here, 50.2 degrees. Okay, it's 0 to 180 degrees here. Therefore, the x will be equals 50.2 degrees, which is in the first quadrant. In the third quadrant, it is 50.2 degrees plus 180 degrees, which will give us the answer, right? 50.2 degrees and 230.2 degrees. Alright, so this is the answer for this question. Okay, we can actually put all the answers together, right? And rearrange from smallest to the largest angle. Okay, from first answer is 0 degrees, followed by 50.2 degrees, followed by 180 degrees, which come from here. Alright, all the angles come from here and come from here. Okay, so after 180 degrees, the next angle will be 230 degrees, and the next angle will be 360 degrees. Okay, so this is the final answer. Okay, now you can try this similar example yourself. Find the angles between 0 degrees and 360 degrees, inclusive, which satisfy the following equation. So A, for bracket sine x plus cosine x equals cosine x. B, 3 sine x cosine x equals to 2 cosine square x. You can pause the video and try to solve it yourself. Okay, now here's the solution. For A, given equation is 4 bracket sine x plus cosine x equals to cosine x. So what we can do is first expand the bracket, which will get 4 sine x plus 4 cosine x equals to cosine x. Then I move the cosine x to the right hand side, right? We get 4 sine x equals negative 3 cosine x. Okay, then we isolate trigo at left hand side, constant at right hand side. So sine x over cosine x will be equals negative 3 over 4. And we know sine x over cosine x is tangent x. So if we tangent x equals to negative 3 over 4. Okay, so we have actually come to the simple trigonometric trigonometric equation, right? Tangent x equals to negative 3 over 4. So we can follow the simple steps, right? First step is to find the best angle. Alpha equals inverse of tangent 3 over 4. And we get 36.9 degrees. Okay, and then tangent is negative. So where is it? So this is tangent is negative, right? So we know that it is in the second and the fourth quadrants. Okay, we can update it on the quadrant diagram. So the second and the fourth quadrants, which is here, and the best angle here is 36.9 degrees, 36.9 degrees. All right, so identify 0 to 360 degrees, 180 degrees here. So we can get the x is 180 degrees minus 36.9 degrees, which is in the second quadrant. 360 degrees minus 36.9 degrees, which is in the fourth quadrant. Okay, so we get the answer is 143.1 degrees and 323.1 degrees. So this is the answer for A. Okay, now we move on to find the solution for B. 3 sine x cosine x equals to 2 cosine square x. So first step is we want to bring everything to the right hand side, which will become 0 equals 2 cosine square x minus 3 sine x cosine x. So the next step is we want to factorize the common factor. So for this case, the common factor is the cosine x. Therefore, the equation is 0 equals cosine x bracket 2 cosine x minus 3 sine x. Okay, then we can solve it. So for this case, we can say that cosine x equal to 0 or 2 cosine x minus 3 sine x equal to 0. Okay, so we solve the first equation first, right? It is a special equal to 0, right? Special angles not in any of the quadrant. So we need to look at the cosine graph. When it is equal to 0, it will be in these 2 points, which is at 90 degrees and 270 degrees. So therefore, x will be equals to 90 degrees and 270 degrees. Okay, now we solve the second equation. So we want to isolate, right? Bring the cosine x at the right side, sine x at the left hand side. So it will be 3 sine x equals to 2 cosine x. Then we isolate the trigos and the constant. Okay, sine x over cosine x equals to 2 over 3. So which is tangent x equals 2 over 3. Now we have come to the simple trigonometric equation. Okay, we can start to follow the simple steps. Step 1, to find the best angle, which is inverse of tangent 2 over 3. Press calculator, we get 33.7 degrees. Okay, and we see that tangent is positive. Okay, so look at the equation, the tangent x is positive. So it is in the first and the third quadrant. Now, right, we can update the quadrant diagram. Okay, it is in the first and the third quadrant. So x will be equals 33.7 degrees and 33.7 degrees plus 180 degrees. Okay, the answer will be 33.7 degrees and 213.7 degrees. Okay, now we can sum up the answers here, right? Arrange from the smallest angle to the largest angle. Okay, so this and this. So x will be equals 33.7 degrees, 90 degrees, 213.7 degrees, 270 degrees. Okay, so this is the answer for B. Do you get the answer correctly? Okay, now let's look at one example, right? Which involves solving trigonometric equation in radian mode. Okay, actually this type of question is pretty much very similar with the previous examples. The only difference is that the angles here is in radian. Okay, and the previous example, the angles is in degrees. Okay, I hope you understand. Radian is another unit for angle. Okay, now look at this example here. Find the angles between 0 and 2 pi inclusive. which satisfy the following equation. So 1 plus 2 sine 3y over 2 plus pi over 12 equal to 0. Okay, so this is the solution. Okay, recall that pi is equals 180 degrees. Okay, so that's why the range 0 to 2 pi is 0 to 360 degrees. Okay, look at the given equation. 1 plus 2 sine 3y over 2 plus pi over 12 equal to 0. Okay, we bring the constant to the right hand side. So the equation will become sine 3y over 2 plus pi over 12 equals to negative 1 over 2. Okay, so we actually have reached the simple trigonometric equation. So you can follow the simple basic steps here, right? Firstly, we want to find the best angle. Alpha is equals, for this case, inverse of sine half. Okay, we ignore the negative sign here, right? We get pi over 6, which is actually 30 degrees. Okay, now sine is negative, which is the third and the fourth quadrant. So how we know, right? Because here this time, right, negative sign. So update the quadrant diagram in the third and the fourth quadrant. So this is the angle pi over 6, this is the angle pi over 6. Okay, from 0 to pi. Therefore, the angle 3y over 2 plus pi over 12, right, equals the third quadrant, pi plus pi over 6. The fourth quadrant, 2 pi minus pi over 6. Okay, which should give us 7 pi over 6 and 11 pi over 6. Okay, so now the next step, let's check the range, right? Given it is from 0 to 2 pi. Okay, it is inside here, 0 to 2 pi inclusive for the range of y. Okay, then for the range of 3y over 2, it will be 0 to 3 pi. Okay, left hand side, okay, times 3 over 2, right hand side also times 3 over 2, you get 3 pi. Okay, after that, right, plus pi over 12, right? 0 plus pi over 12, I get this, pi over 12. 3y over 2 plus pi over 12, get this. Okay, 3 pi plus pi over 12, I get 37 pi over 12. Okay, so now we can actually try to consider the answer here, right? For the 7 pi over 6. Okay, we turn one more cycle, right? We plus with 2 pi. See what will happen. We get 19 pi over 6. Okay, so this is out of the range of 37 pi over 12. Okay, so we will reject this answer. Okay, therefore, right, well, our 3y over 2 will be 7 pi over 6 minus pi over 12. Okay, so we can continue here, right? So make y the subject. And then the next angle will be 11 pi over 6 minus pi over 12. Okay, which should give us the first angle is 13 pi over 12, second angle is 7 pi over 4, right? Now make y the subject. So both sides times 2 over 3. The first angle is 13 pi over 12 times 2 over 3. The second angle is 7 pi over 4 times 2 over 3. Okay, we get the answer. Y is 13 pi over 18 and 7 pi over 6. So this is the answer for this question. Okay, so now it's your turn to try similar example yourself. So find the angle x between 0 and 4. Okay, be careful, right? It doesn't necessarily, the range must always be from 0 to 2 pi or 0 to 360 degrees. For the equation, 3 cosine 2x minus 1 equals to 2. Okay, so you can pause the video and try to solve it yourself. Okay, now let's look at the solution. Given equation, 3 cosine 2x minus 1 equals to 2. Okay, notice that 1 is in radian. Okay, don't treat it as 1 degrees. Okay, bring the constant to the right hand side. Okay, what we need to do for this case, it will become cosine 2x minus 1 equals 2 over 3. Then we actually have reached the simple trigonometric equation. So we can just follow the steps. Step 1 to find the best angle alpha. For this case, is inverse of cosine 2 over 3. Okay, when you press calculator, it will give us 0.8411 radian. Okay, you need to make sure that your calculator is in radian mode before you want to calculate the answer. Or you can, if your calculator is in degree modes, right, the calculator will give you the answer in degrees. You can convert it to radian by just taking the angle in degrees, right? You times it pi divided by 180 degrees. Okay. Now we check the cosine is positive for this case, then it will be in the first and the fourth quadrant. Okay, we can draw the quadrant diagram. First and fourth quadrant, right? Which is and the best angle here. Okay, so the angle 2x minus 1 will be equal 0.8411 for the first quadrant and 2 pi minus 0.8411 for the fourth quadrant, which will give us answer 0.8411 and 5.4421. Okay, now we check the range. Given that the range is for x is 0 to 4, okay, the range for 2x will be 0 to 8. Okay, the range for 2x minus 1 will be -1 to 7. Therefore, right, 2x minus 1 equals 0.8411, 5.4421. Okay, so we can consider add one more cycle. Or for this case, actually, we should consider the negative angle, right, which is negative 0.8411. Okay, it is still within the range. Okay, so we need to check the range -1 to 7, right? So negative 0.8411 is still within the range. Okay, consider the negative angle here. Now we make x the subject, right? Then the first angle will be 0.8411 plus 1 divided by 2. Second angle 5.4421 plus 1 divided by 2. And the third angle negative 0.8411 plus 1 divided by 2. Right, then we get answer 0.921, 3.22, and 0.0785. Okay, so this is the answer for this example. Do you get answer correctly? Principal values. Okay, what is principal values, right? So actually principal values, if you involve different trigo, it can be sine, cosine, or tangent. So for the equation y equals sine x, where the range of y is -1 to 1 inclusive, the principal value of x or inverse of sine y are the range of inverse of sine y from -90 degrees to 90 degrees, or if it is in radian, inverse of sine y, the range is from -pi/2 to pi/2. Okay, so this is principal values for y equals to sine x. For y equals to cosine x, okay, where the range of y is from -1 to 1, the principal values of x of inverse cosine y are 0, the range is 0 to 180 degrees. Or in radian mode, the range of cosine inverse cosine y is from 0 to pi. Okay, for the equation y equals tangent x, where the y range is from -1 to 1. So the principal values of x or inverse of tangent y are, right, the range will be from -90 to 90 degrees, or in radian, it will be -pi/2 to pi/2. Okay, so now notice that for principal values of the sine function, it will be in the first and the fourth quadrant. Okay, the principal values for the cosine function, right, it will be in the first and the second quadrant. And for the principal values of tangent function, it will be in the first and the fourth quadrant. Okay, now let's look at one example on principal values. A. State the values between which the principal value of inverse of sine x must lie. B. Find the principal value of inverse of tangent -1 over sub 3 in radian in exact form. And C. Evaluate the principal value of inverse of cosine -0.8 in degrees. Okay, here's a solution. For A is very straightforward, right? We want to find the range, okay, of the principal value of inverse of sine x. It is from -90 degrees to 90 degrees. Or if it is in radian mode, it will be -power 2 to power 2. Answer for B, right? So firstly, we want to find the best angle first, right? Inverse of tangent 1 over sub 3 will be power 6, okay, which is the 30 degrees, right? Okay, this is a standard angle. Okay, so now we know that, right, the range of the principal value of inverse tangent will be in the first and the fourth quadrant. Okay, so since this is a tangent is negative here, it should be in the fourth quadrant. Okay, so therefore the answer will be -power 6. For C, right, again we are very similar with B. We want to find the best angle. Okay, inverse of cosine of 0.8 is 36.9 degrees. So cosine is negative, right? And principal value for cosine, it is in the first and the second quadrant. Therefore, it should be in the second quadrant. Okay, then the answer will be 180 degrees minus 36.9 degrees. And the answer is 143.1 degrees. Alright, now can you try this similar example yourself? A. State the values between which the principal value of cosine inverse x must lie. B. Find the principal value of inverse of sine -1 over 2 in radian in exact form. C. Evaluate the principal value of inverse of tangent -1 in degrees. Okay, you can pause the video and try to solve yourself. Okay, here's the solution. For A, right, okay, the answer also very straightforward. Okay, we know that the range of the principal values of cosine inverse x, it is 0 to 180 degrees. Okay, it is in the first and the second quadrant. So that's why the range is from 0 to 180 degrees, or if it is in radian mode, it will be from 0 to pi. For B, right, okay, so first step we want to find the best angle. Inverse of sine half, right, is power 6. And then the principal value of inverse sine will be the first and the fourth quadrant. Therefore, and for this case, sine is negative, it will be in the fourth quadrant. So principal value of -half, it is -power 6. Okay, for C, right, now what we want to do is find the best angle. Inverse of tangent 1 will be 45 degrees. So we know that principal value for tangent function will be in the first and the fourth quadrant, and it is a negative tangent, so it will be in the fourth quadrant. The answer will be -45 degrees. Alright, so do you get the answer correctly? Okay, now let's learn how to sketch trigonometric graphs. The very first thing you need to do is you need to know how to draw the basic graphs. Okay, for sine function, sine graph y equals to sine x. Okay, it will look like this. Okay, so firstly you need to recognize the shape of sine x. Okay, and then you need to label the angles or label the x-axis. For the zeros, right, y is 0, it will be at 0 degrees, 180 degrees, and 360 degrees. Okay, and then the peak, right, or the maximum will be 1, the minimum will be -1. So for sine function, when the maximum at 1, right, when the angle is at 90 degrees, the maximum -1 when it is at 270 degrees. Okay, so this is the basic graph for sine function. Make sure you know the shape of the graph and the angles for the special values of 0, 1, and -1. Okay, and second basic graph you need to know is y equals cosine x graph. Okay, so firstly, again, the same, right? You need to recognize the shape of cosine graph. It should look like this. And then the angles when y is 0, it will be at 90 degrees and 270 degrees. Okay, the maximum will be 1, minimum is -1. Okay, when the angle is 0 and 360 degrees, the y value will be maximum, which is 1. And the y value will be minimum, which is -1 when the angle is at 180 degrees. Okay, so this is the basic graph for cosine function. Okay, next, you also need to know the basic graph for tangent. Okay, this is how it looks like. Okay, it will be slightly different with the sine and cosine graph. Okay, so firstly, you need to draw the asymptote at 90 degrees and 270 degrees. Okay, after that, right, recognize, all right, when y equal to 0, okay, it will be at 0 degrees, 180 degrees, and 360 degrees. Okay, after that, you can draw the curve. From 0 to 90 degrees, it will curve up like this. From 90 to 180 degrees, it will curve like this, okay, in this shape. Then 180 degrees to 270, right, the shape will look like this. From 270 to 360, okay, the shape will look like this. Okay, and from here you can see that the shape of the graph repeats for each 180 degrees. Okay, from 0 to 180 degrees, the shape is the same as from 180 degrees to 360 degrees. Okay, and one more thing you need to take note is when the y is equal to 1, right, it is at the angle of 45 degrees, 225 degrees. And also when y equals to -1, the angle will be at 135 degrees and 315 degrees. Okay, so this is the basic the graph of the basic tangent function y equals to tangent x. Okay, in general, the equation of the sine, right, will be y equals to a sine bx plus c. For cosine, it will be y equals to a cosine bx plus c, where the a, b, and c are constants. Okay, so sometimes the question will ask you, right, what is the amplitude for the function? The amplitude will be equals to the value of a. The period, okay, for sine and cosine function, it will be 360 degrees over b or 2 pi over b if it is in radian mode. Okay, so you need to understand that the meaning of b, right, it is you can interpret it as b cycles in 360 degrees. Okay, so that's why the period will be 360 degrees divided by b or 2 pi over b. Okay, yeah, over here b indicates the number of complete rotations in 360 degrees or 2 pi. Okay, now if a is negative, then the graph is reflected along the x-axis. So C indicates the shifting of the graph. Okay, so if C is positive, right, the graph will shifts C units to the upward direction. If C is negative, then the graph shifts C units to the downward direction. Okay, if A is positive, the maximum value will be a plus c. The minimum value will be -a plus c. If a is negative, the maximum value will be -a plus c. Minimum will be a plus c. Okay, now we move on to the tangent function. So tangent function will be different, different from sine and cosine function. So how different it is right now? If you look at the previous slide, right, and you look at the graph of tangent, we can see that we can't find the maximum, we can't find the minimum. So in other words, right, there is also no amplitude. Okay, so A will only determine the value of y when the bx is at 45 degrees. Right now, period is 180 degrees divided by b, or pi divided by b. Okay, why is it so? Right, remember when we look at the basic graph for tangent function, okay, I mentioned that every 180 degrees, right, we can see that the pattern of the graph repeats. So that's why the period is 180 degrees divided by b, or pi divided by b. Okay, what happens if a is negative? If a is negative, the graph is reflected along the x-axis. Okay, C is also C indicates the shifting of the graph. If C is positive, that means the graph shifts C units to the upward direction. If C is negative, the graph shifts C units to the downward direction. Okay, so please understand the meaning of the constants A, B, and C for these three different trigo function: the sine function, cosine function, and the tangent function. Okay, so now let's learn how to sketch some trigonometric graphs, okay, with certain values of A, B, and C. Okay, the very first graph will be the basic graph y equal to sine x, which we actually have seen previously, right? So this will how it looks like. Okay, the peak will be 1. Okay, the minimum point will be -1. The angles is 0, 180 degrees, and 360 degrees when y equal to 0. Okay, and when y equals to 1, the angle is 90 degrees. When 1 equals to -1, the angle is 270 degrees. Okay, so this is the graph of y equal to sine x, which is the basic graph for the sine. Next, we move on to y equals to 2 sine x, okay, which means that the amplitude is 2. So what will happen to the graph? Okay, actually it is pretty much very same as the first graph y equal to sine x. Okay, the only difference is that the amplitude now is 2, right? Then the maximum point will be 2 and minimum point will be -2. The angles are the same. So when y equal to 0, it will be at 0, 180 degrees, and 360 degrees. When the y equals to 2, right, it will be at 90 degrees. When -2, it will be at 270 degrees. Okay, so this is the graph of y equals to sine 2 y equals to 2 sine x. Okay, what about y equals to sine 2x? Okay, remember how we want to interpret, for this case, the value b is 2, right? So it means that in 360 degrees, there are 2 complete cycles. Okay, start from 0 to end at 360 degrees, we have 2 complete cycles. Okay, so the next, and over here, this is between 0 to 360 degrees, right? It is 180 degrees. Between 0 to 180 degrees, it is 90 degrees. Between 180 degrees to 360 degrees, it is 270 degrees. Okay, so this is how we label the x-axis initially, right? Then the next thing we need to do is, right, the maximum point is 1. Okay, the minimum value should be -1. Okay, so what will be the angle? When y equals 1, it will be at 45 degrees, which means it is actually between 0 to 90 degrees. When it is y equals -1, it is at 135 degrees because it is between 90 to 180 degrees. Okay, followed by the next one. Okay, y equals 1, it is at 235 degrees. Y equals to -1, it is at 315 degrees. Okay, so this is the graph of y equals to sine 2x. Now, let's look at y equal to sine 2x plus 3. Okay, basically it is very similar with the third graph. Okay, y equal to sine 2x. Okay, the only difference is that we plus the 3 here, right, which is plus c here. Remember the meaning of plus 3? It means that we shift 3 units, the whole graph, right, 3 units to the upward direction. Okay, now how we want to sketch it? So firstly, we can just repeat the same process when we want to draw the graph of y equal to sine 2x. But now we start with the dotted line first. Okay, so 2 complete cycles. Okay, the maximum point should be 1, minimum will be -1, and in between is 0. Okay, but we plus 3 here, right? So all these numbers 1 plus 3 we get 4, 0 plus 3 we get 3, -1 plus 3 we get 2. So this is how we sketch the graph, right? Okay, and the graph now has been shifted 3 units to the outward direction. Then the next thing we need to do is we can draw the x-axis now and label it. Alright, so at the end of this graph is at 360 degrees. So between 0 to 360 will be 180 degrees. Between 180 degrees, 0 to 180 degrees, right, will be 90 degrees. Okay, between 180 degrees to 360 degrees, it will be 270 degrees. Okay, next, between 0 to 90 degrees, which should be at the maximum value, it is 45 degrees. Between 90 to 180 degrees, it will be 135 degrees. 180 to 270 degrees, right, the number is 225 degrees, which at the peak value. And 270 to 360 degrees, right, it will be at 315 degrees. Okay, so this is the graph of y equals to sine 2x plus 3. Okay, now we move on, right, to this equation, y equals to 2 sine 2x plus 3. Okay, so compare the difference, right, between this and this one. Okay, the only difference is that the amplitude now has changed to 2. Alright, so we want to sketch this graph. The process is pretty much same as the previous graph, right? The only difference is that when we want to draw the maximum value, right, it becomes 2. The minimum value is -2. Okay, so in 360 degrees, there are 2 complete cycles. Okay, and between here is 0. Okay, this is dotted line. And now we take care of the shifting. Plus 3, right? All these important numbers, right? 2 plus 3, you get 5. 0 plus 3, you get 3. -2 plus 3, you get 1. Okay, and now we can draw the x-axis and label. So at the end of the graph is 360 degrees. Between 0 to 360 degrees is 180. Between 0 to 180 is 90 degrees. Okay, and then now between 180 degrees to 360 is 270. Okay, and between 0 to 90 degrees, it is 45 degrees. Between 90 to 180 degrees, it is 135 degrees. Between 180 degrees to 270 degrees, it is 235 degrees. Between 275 degrees to 360 degrees, it is 315 degrees. Okay, so this is how we draw the graph of y equals to 2 sine 2x plus 3. Okay, how about this? When y equals to negative sine x, okay, so what it will be the impact when there's a negative sign in front? So this actually means the a is -1. Alright, so the graph, we should start from the very original graph, right? Y equal to sine x. We'll move on to negative. So the whole graph, right, will just reflect along the x-axis. The positive becomes negative, the negative becomes positive. Okay, but the angles remain the same. So when y equal to 0, it will still be at an angle of 0, 180 degrees, and 360 degrees. Alright, in between 0 to 180 degrees, it is 90 degrees. Between 180 degrees to 360 degrees, it is 270 degrees. Okay, so this is the graph of y equals to negative sine x. Now, you can take your time, understand all the graphs here. Once you have understood the concept behind, right, you can try to draw these graphs yourself. Actually, it is very similar with the graphs that we have discussed. The only difference is that now we change the trigo to cosine. So y equals to cosine x. Okay, how the graph will look like? Y equals to 2 cosine x, y equals to cosine 2x, y equals to cosine 2x plus 3, y equals to 2 cosine 2x plus 3, and y equals to negative cosine x. Okay, so please take up a piece of paper and try to draw yourself here. I'm not going to show here because the concept or the idea is pretty much very similar with the sine graph. Okay, take your time and try to draw yourself. Alright, now let's look at one example in sketching of trigonometric graphs. Okay, the question is, on the same diagram, sketch the curves y equals to 4 sine x plus 1 and y equals to 2 cosine x for the interval of the x, right, is between 0 to 2 pi, and hence deduce the number of solutions in the interval of the equation 2 cosine x equals 4 sine x plus 1. Okay, so here's the solution, right? So we can actually draw the graph, right, one by one. For y equals to 4 sine x plus 1, okay, start with, we need to be careful here because plus 1 means we shift 1 unit to the upward direction. Okay, that's why we start with the dotted line, not a solid line. Okay, so maximum is 4, minimum is negative 4 because the amplitude is 4. Okay, sine x, so that means there's one cycle. All right, okay, now shifting plus 1, so 0 becomes 1, 4 becomes 5, negative 4 becomes negative 3. Okay, so after that we can draw the x-axis now, okay, where it should be between 1 and negative 3, and it is closer to 1. So this is the x-axis. Next, right, we can start to label, right, at the end of this graph is 2 pi, okay, because the question requires us to leave the answer in radian. Okay, and the middle of this graph, okay, it should start from here, right? Remember, it's this point. It is pi. Right, between 0 to pi, it will be pi over 2, and it is the maximum value 5. In between pi to 2 pi, it is 3 pi over 2, okay, which is the minimum value, negative 3. So this is the graph of y equals to 4 sine x plus 1. Now we move on to sketch the graph of y equals to 2 cosine x. Okay, on the same graph. So we need to label, right? The maximum is 2 because the amplitude A is 2. Okay, the minimum is negative 2. Alright, now it is a cosine graph, right? So that means when the angle is 0, the y is 2. When the x is pi over 2, y is 0. When x is pi, y is negative 2. When x equals 3 pi over 2, right, y will be 0. When x is 2 pi, the y will be 2. Okay, so we have plotted the important points here. Now we can join them together, right? So this is how it looks like. Okay, so we have drawn these two graphs into one diagram. Now, the next question, right, is to determine the number of solutions. Okay, and it will be the number of intersection points of these two graphs on the same diagram. Okay, so this is the first point. Look at the arrow mark here. This is the first point, and this is the second point. Okay, so anymore, there is no more intersection point. So number of solution will be equals 2. Okay, now you can try this similar example yourself. Given that y equals a sine bx plus c, where a, b, and c are positive integers, has a period of 90 degrees. Number 1, state the value of b. 2. Given further that the maximum and the minimum values of y are 10 and 4 respectively, find the values of a and c. 3. Using the values of A, B, and C that you have found in part 1 and part 2, sketch the graph of y for the range of x from 0 degrees to 180 degrees. Okay, you can pause the video and try to do it yourself. Okay, so here's the solution, right? For the first question, we know that period is equal to 360 degrees over b, and given the period is 90 degrees, therefore b will be 360 degrees divided by 90 degrees, and the answer is 4. For question number 2, right, given that the maximum value is 10, therefore a plus b equals to 10. The minimum value is 4, therefore negative a plus c equals to 4. Then we can solve simultaneous equation to find a and c. So I can label this as first equation. This is the second equation. So the first equation plus with the second equation, we get 2c equals to 14 and c is 7. Therefore, a will be 10 minus 7, which is 3. Okay, so question number 3, we can rewrite the equation becomes y equals to 3 sine 4x plus 7. And we know period is 90 degrees. So we want, the question asks us to draw from 0 to 180 degrees. Therefore, we need to draw 2 complete rotations in 180 degrees. Okay, now we can start to draw the graph. So we can draw the dotted line because there is a shifting. Okay, so this is 0. This is amplitude 3. Minimum is negative 3. Okay, 2 rotations. So 1, 2. Okay, and then after that shifting, right, plus 7. So 0 becomes 7. 3 becomes 10. Negative 3 becomes 4. Okay, then we can draw the x-axis, which is here. Okay, at end of the graph is 180 degrees. In the middle is 90 degrees. Between 0 to 90 degrees is 45 degrees. Between 90 to 180 degrees is 135. Okay, so between 0 to 45 will be 22.5 degrees. Between 45 to 90 degrees is 67.5 degrees. Between 90 to 135 degrees will be 122.5 degrees. And lastly, between 135 degrees and 180 degrees is 157.5 degrees. Okay, so this is the graph of y equals to 3 sine 4x plus 7 for the range of x 0 to 180 degrees. Okay, so do you get the answer correctly? Okay, now let's look at one example related to tangent graph. Okay, so here is the question. The diagram shows part of the graph of y equals to a tangent bx plus c. Find the value of a, b, and c. So this is the diagram. Okay, how we want to find the value of a, b, and c. So the solution is, okay, we want to see, right, what is the period. So this is the period. Okay, from negative pi over 4 to pi over 4, it is, to get the period is pi over 4 minus negative pi over 4, we get pi over 2. Okay, so for the tangent graph, right, so the period will be pi over b, which is equals pi over 2. Therefore, b will be equals to 2. Right, next, I want to find, okay, c, right? So we see that the horizontal dotted line is the what we call the principal axis of the graph. Okay, and we can see that it is a shifting of 4 units to the upward direction. Therefore, c will be equals to 4. Okay, now how to find the value of a? We can rewrite the equation becomes y equals to a tangent to x plus 4. After that, we take this point. Okay, the coordinates is pi over 8 and 6. So that means when y is 6, the x is pi over 8. So this is the equation. 6 equals to a tangent 2 bracket pi over 8 plus 4. Now we want to solve this equation. The a will be 2. Okay. Okay, now let's discuss an example to find a particular angle in a right angle triangle. So here's the example, right? The diagram shows a right angle triangle ABC in which AB is XCM, angle ACB is 30. Okay, let me show you the diagram first. Okay, angle ACB is 30 degrees, angle ABC is 90 degrees. The point D lies on the BC such that 3BD equals 2DC. Show that the angle CAD equals 60 degrees minus inverse of tangent 2 sub 3 over 5. Okay, here's a solution. So first we start from the triangle ABC. Okay, the tangent 30 degrees equals x over BC, right? Tangent opposite over adjacent. So tangent 30 is 1 over sub 3, okay, equals x over BC. Therefore, BC will be sub 3x. Okay, and then we move on, right, to given that the 3BD equals to 2DC. So in other words, right, BD is 2 units and DC is 3 units. Therefore, right, BD is 2 over 5 BC. And we know that BC is sub 3x, so therefore BD is 2 sub 3 over 5x. Okay, from here, right, we now look at the triangle ABD. So tangent angle BAD will be equals BD over AB. Okay, then we substitute, right, the value BD is 2 sub 3 over 5x, AB is x. So it will be 2 sub 3 over 5. Okay, now we move on to angle BAD. It will be inverse of tangent 2 sub 3 over 5. Okay, so angle BAC will be equals 90 degrees minus 30 degrees, which is 60 degrees. Therefore, angle CAD will be angle BAC minus angle BAD, which will become 60 degrees minus tangent inverse 2 sub 3 over 5. Okay, so I compare the answer with the answer that they want me to show. Okay, it is the same. Therefore, I have shown the solution. Okay, now here is another similar example that you can try yourself. Okay, I give you this diagram. The question is, the diagram shows a triangle ABC in which AC equals to XCM, BAD, angle BAD is y degrees, angle BCA is 90 degrees. The midpoint BC is D, and angle BAC is 30 degrees. Okay, show that. Okay, number one, the length of AD is exactly 13 over 12 x cm. Okay, angle y, right, y degrees will be 30 degrees minus tangent 3 over 6. Okay, so you can pause the video and try to solve it yourself first before I show you the solution. Okay, so here's the solution. Number one, right, the length of AD. So firstly, right, we look at the angle 30 degrees. So tangent 30 degrees will be BC over AC. Okay, so tangent 30 degrees is 3 over 3, and AC is x. So therefore, it will be 3 over 3 equals BC over x. BC will be 3 over 3x. Okay, and we know that CD is half BC. Okay, so it will be 3 over 6x. Okay, and from here, by Pythagoras theorem, AD equals x squared plus x over 4 squared. Okay, so we will get x squared plus 3 over 6 x squared. Okay, which is 13 over 12 x cm. So I have shown the length of AD is exactly equals 13 over 12x. Alright, now number 2, we start from tangent angle DAC equals CD over AC, okay, which will give us 3 over 6 x over x. Okay, x cancel each other. We will get 3 over 6. So angle DAC will be inverse of tangent 3 over 6. Now the y angle, right, will be equals angle BAC minus angle DAC. Okay, so BAC is 30 degrees. Okay, DAC will be tangent inverse 3 over 6. Okay, so now compare the answer that they want me to prove is the same. So I've shown the angle y is 30 degrees minus inverse of tangent 3 over 6. Alright, so do you get the answer correctly? Okay, now let's talk about the real life modeling using a trigonometric function. So here's an example. The population of mosquitoes in a particular district is primarily influenced by precipitation, humidity, and temperature, and is modeled by the function p equals 50 cosine pi over 25t plus 900, where p is the mosquito population in thousands in week t of the year. So using this model, number 1, find the period of the function. 2, sketch a graph of the function over one period. 3, find the maximum and the minimum value of p. 4, estimate the number of weeks within the year that the population is less than 915,000, giving your answer correct to the nearest whole number. Here's the solution. So number 1, right, to get a period is just 2 pi divided by b, right, which is 2 pi divided by pi over 25. It is 50 weeks. Then number 2, to sketch it, right, we can start sketching, and there's a shifting of 900. So we start with the dotted line with 0. The maximum or the peak is 50. The minimum is negative 50. Okay, and then this is one complete cycle. Okay, after that we update the value of p, right, because shifting 900, 0 becomes 900, 50 becomes 950, so negative 50 becomes 850. Okay, and then we can draw the x-axis at the bottom. Okay, then we label the angle. This is 0, this is 50. Okay, because the period is 50, right, between 0 to 50 is 25, and between 0 to 25 is 12.5. Between 25 to 50 is 37.5. Okay, so this is the graph of p equals to 50 cosine pi over 25t plus 900. Then to answer number 3, so from here we can, from the graph, right, you can see maximum is 950,000, minimum is 850,000. Number 4, now we can estimate the number of weeks, right? Just substitute. Okay, the p is 950. Okay, 915 equals 50 cosine pi over 25t plus 900. Then you solve this equation. Okay, we get the t will be 10.1, or t equals to 39.9. Answer nearest to the 3SF. Okay, so we want to know the number of weeks. It should be 39.9 minus 10.1. Okay, which is about 30 weeks. Round it off to the whole number. Alright, so now you can try yourself here. A scientist is conducting an experiment which involves a transmitter sending a signal to a receiver. The signal received is measured in millivolt and is modeled by the function s equals 2 cosine 4 pi t plus 5, where t is the time measured in milliseconds. Using this model, number 1, state the amplitude of and the frequency of the signal. 2, sketch the graph of the signal over one period. 3, state the maximum and minimum values of the signal. The signal will be distorted when passes through a filter if it is less than 3.5 millivolts. Determine how long will the signal be distorted in one cycle. Alright, so you can pause the video and try to solve it yourself before I show you the solution. Okay, here's the solution. Number 1. Okay, from the equation, the amplitude is 2. The period will be 2 pi over b, which is 4 pi, and we get 0.5 milliseconds. So the frequency will be 1 over period, which is 2 kilohertz. Okay, number 2, sketch a graph, right? Okay, so there's a shifting of 5 units to the upward direction. Okay, we start with the dotted lines with 0. The amplitude is 2. The minimum is -2, right? And then one complete cycle. The period thereafter that shifting, right? 0 becomes 5, 2 becomes 7, -2 becomes 3. Then we can start to draw the x-axis, okay, in milliseconds. So start with 0 and at 0.5 because the period is 0.5 milliseconds. Okay, in between, right, is 0.25. So between 0 to 0.25 will be 0.125. Between 0.125, 0.25 to 0.5 it will be 0.375. Okay, so this is the graph of s equals to cosine 4 pi t plus 5. Okay, now I can state the maximum and minimum value from the graph, which is maximum is 7 millivolts, minimum is 3 millivolts. Okay, now to answer the last question, right, from the equation s equals to cosine 4 pi t plus 5. So the s is 3.5. Now we can solve this equation, right? Cosine 4 pi t equals to -0.75. The angle, right, or the t will be at 0.1925 or 0.3075. So in other words, in between these two time, right, the signal is distorted. So how long is it to distorted period? It will be 0.3075 minus 0.1925, which is 0.115 milliseconds. Alright, so do you get the answer correctly? Alright, that's all for this video. Thanks for watching. Do you have any questions or thoughts to share? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Until then, I will see you in the next video. Have a great day ahead.